Hi everybody, good afternoon. It's Friday. This is week 3 of us doing some fun educational activities while everybody's at home, thinking of things to do during our downtime. And I'm trying to come up with things that you can do at home using things you have around the house. Because we're trying to minimize going out, getting the groceries and things that we need, and plus we're trying to keep our kids busy and minimize screen time. So I'm hoping that we can continue to come up with things for you guys to do, just to pass the time but make it productive as well. If you want to use some of these things we're doing as part of your education, there's lots of ways you can extend the learning. So as I think of things as we're talking about them, I'll try to throw those out there too. If you have questions, please feel free to comment and I'll come back and take a look at those as well. My name is Seligson. I am a Apology of Science author. Worked as a marine biologist before I had kids and homeschooled my kids kindergarten through 12th grade. So I love talking about science. I love talking about all the fun things that we can do in all the different realms of science, but I really love talking about marine biology. And in particular, I love talking about sharks because when I worked at Disney, I worked in their predator department. So I was responsible for feeding, care, collection of all the predators, and including sharks. And they're really fascinating animals, very different from dolphins, which we talked about yesterday. And we're going to talk now today about sharks. We're probably going to talk about sharks on Monday as well. But I wanted to talk just a general introduction about sharks, and we're going to do a fun little activity about how they're able to stay in the water column. So sharks, first of all, are fish. They are a specific kind of fish in a group of fishes that include the cartilaginous fishes. And what that means is that their body support structure, their skeleton, is completely made of cartilage. They have no bone cells. And so they're made of cartilage, which is the same stuff that's in the upper part of your ear. It's flexible, it provides some support, but it's also extremely flexible versus bones, which are very hard. Now, some parts of a shark's skeleton have been calcified, like their jaw and their teeth, but they don't have bone cells, and so their tissue is completely cartilaginous. Now, you may have heard me say the word fishes, and I don't know if any of you guys cringed when you heard that, but that's the actual grammar that goes with science. When we are speaking about a single individual fish, we use the term fish. When we talk about a group of those individuals of the same species, we use the term fish, plural. But when we're talking about multiple individuals from multiple species, we use the word fishes. So there's a distinction there. So fishes is actually a word, but it's a word that we use in scientific circles to be a little more specific about what we're talking about. All right, we're going to talk about sharks' teeth. And I have this visual here, is a pretty fun one. The dark colored teeth on top represent fossilized shark's teeth. The white ones are non-fossilized. When something becomes fossilized, the cells actually have died and are replaced with minerals. So they become like rock, and they're usually a darker color. Sharks' teeth are actually easy to collect. They wash up on shore all the time. That's because sharks lose their teeth regularly. Having sharp teeth is a specific requirement for sharks to stay alive. It's a survival need. And so they have to have a sharp set of teeth. When sharks will bite into their food, they don't chew their food. They bite into their food and then they turn their head from side to side and cut off a chunk of food and swallow that whole. And a great example of that is what we do with scissors. Scissors are two cutting surfaces that come together. And when they come together, they tear or break. And that's what sharks' teeth do. When those sharp teeth come together, they cut. And that cutting is what takes off the piece of food that they swallow. Because they have to have a sharp set of teeth, they will lose their teeth and replace them with new ones regularly. They have rows and rows of teeth, and as an old one falls out that's dull, a new one pops up from behind, kind of like a conveyor belt, to replace it. Some studies have been done on sharks over the years, and in some species, they'll replace an entire set of teeth every 10 to 12 days. That's pretty fast. And that's why sharks' teeth are easy to find. They lose them on a regular basis. Remember yesterday we talked about dolphin teeth and other toothed whales, and we made this fun little, oh, I lost a tooth here. There we go. Dolphins don't lose their teeth. Toothed whales do not lose their teeth, but they have cone-shaped teeth. And those cone-shaped teeth they keep, and they use those to grasp, and then they will orient the food, their fish, and swallow it whole head first. Different from a shark that bites and takes off a piece and swallows that whole. Okay, so sharks will lose their teeth on a regular basis, and interestingly, sharks' teeth are uniquely shaped based on the species of shark. So if you'll look here at this, let's see, here's a tiger shark right here. You see how it's got a dent right there? It comes like a little indentation. That is characteristic of a tiger shark tooth. Well, right here is an extinct tiger shark tooth. Okay, same little indentation on the side, and the various types and shapes of teeth are how we can identify what species of shark that these came from. So when you find shark's teeth, you can actually know where it came from, which kind of species. Now these two gigantic ones on each side, those come from the Megalodon sharks, which are an extinct species that we think. There may be some of these guys still living in the deep ocean. We don't know. But one reason is because the deep ocean is so deep that we aren't able to stay down there very long. And so daily, scientists who have deep submersibles that they're remotely driving find new species of organisms in the ocean, because when we are down that deep, we can only stay in one spot for a short period of time, and if something big has passed, we've missed it. So who knows? We may find that these guys, there may be some of them alive today. We haven't seen any, so at this point they're considered an extinct species. Now look at that tooth. Can you imagine how big that shark's jaw is? It must be huge. This is an image right here of a bull shark jaw, which is actually not to scale compared to these teeth. Bull sharks can have a little bit larger jaw than this, and their teeth are bigger than that as well. In fact, you can see right here, this is a bull shark tooth right there. And so the little teeth that are shown here are smaller than this. So this is the only thing that's not to scale compared to all the rest of them. All right, so sharks have to have sharp teeth. Not only do they have sharp teeth in their mouths, do you know that their scales on their bodies are teeth also? They have teeth all over their bodies. Their scales are a type of tooth called a denticle. If you were to look at their skin under the microscope, they look like rows and rows of tiny little teeth. And if you were to pet a shark, which I don't recommend you do unless you're with somebody who knows what they're doing, it feels like sandpaper. So sharks are very interesting in the fact that they have a good design for how they behave in the water and how they get their food. What we're going to talk about today specifically with sharks is how they stay in the water, how they maintain their buoyancy, and in comparison to how other fish do, bony fishes in particular. Bony fishes have a unique organ that's called an air bladder or a swim bladder, and it's basically a balloon. It's a container or a bladder that can fill with air. They also can reduce the amount of air in that bladder, and the more air they put in it, the higher they float in the water column. If they remove some of that air, then they sink lower. And that's how a fish can maintain its buoyancy, its position in the water. If it's positively buoyant, it's gonna float. If it's negatively buoyant, it's gonna sink. If it's neutrally buoyant, it stays in one spot. And that's a good thing for a fish, because a fish doesn't want to expend a lot of energy just to stay in one place. And so sharks don't have that. Sharks do not have a swim bladder. What they do have is a fatty liver, a very, very large liver. And their liver takes up a good portion of their body. If you've ever had an opportunity to dissect a shark, then you will see how much of its body is taken up inside by liver. In fact, it's so much is taken up inside, they have a spiral staircase-shaped intestine to create enough surface area for their food. Well, I want to talk about density, and that's what we're talking about. We're talking about buoyancy. Why is a fatty liver helpful for a shark to remain floating in the water, or at least not to have to swim really hard to stay up in the water column? Well, when something is denser than something else, the material that makes up that stuff is packed together tightly. So if you imagine each one of these, this is a little toy I have here of my kids, and if you take just a couple of these pieces off, you'll see they're small, and I'm linking them together into what we might call a molecule, okay, or a couple of molecules together. When they are tightly packed together, they don't take up a lot of space, okay? This is called dense material. It's dense. There's a lot of stuff tightly packed together. When it's not dense, it's opened up and there's more air spaces in between the stuff. And so there's less material in this space than there was when it was packed like this, okay? So tighter packed means greater density. Things that are less dense will float above things that are more dense. You might say heavier or lighter, but we really like to use the term dense. And so fat is less dense than water is and will float on the surface. So let me do a couple different examples to show you what I'm talking about. We're going to make a couple of we're going to do a shark swim bladder, which is air. And I'm just going to fill it up a little bit. Okay, this is my air shark swim bladder. I'm sorry, fish swim bladder. And I'm going to try to remove this little loopy part at the top of the balloon because sometimes it contains air in it, and I don't want to affect my results of my experiment. Okay, so this one's my air. I'm going to set it aside. Now I'm going to do one with water. So I'm going to use a funnel. Let's see if you guys can see what I'm doing here. All right. Orange will be the water one. Actually, we should make blue the water. Easier to remember because once we get stuff in here, we're going to forget. So blue is our water. Okay, and you can do this at home if you want. If you've got a vase, if you have a 2-liter bottle and you want to just cut the top off of it to play with, you can use a smaller water bottle as well to do this with. And I'm going to fill this up as much as I can. In fact, there's water up in my funnel, and I'm going to pinch it off and take the funnel off, and it's going to be a little messy, but that's why I have a tray and some paper towels. I want this to have no air in it. I want it to be just complete. There's water squirting out right now as I'm tying the knot. I want to get all the air out. I want it to just be filled with water. Okay, and then I'm going to cut off this little loopy part here again. Okay, so we have air, we have water, and the last one we're going to use orange. We'll use this one as our oil. Close that off. What do you think will happen when I put each of those in the tray or in the vase of water? Water and water have the same density, don't they? So it should float actually right at the surface of the water, right? All right, so think about what the air will do. Is air more or less dense than water, do you think? And then what about oil? Oil is what is a fatty material made of fats. Again, this is the messy part. I've got the level of oil up to here because I want to make sure there was no air here. I'm going to pinch it off and tie it, which means oil is going to spill. So I'm going to put it over here, over my cutting board here, or my cookie sheet, and tie it. And I tried to make, now this is going to be slippery. I tried to fill them with the same amount. I didn't overfill them so they weren't stretchy. So the balloons are all the same size. Okay. I have a little pocket of air trapped in my knot. That's not good. I'm going to see if I can't pinch. Actually, that's oil. So I think I'm good. Pop this one. Yeah, that's oil. Okay, that's not air, that's oil. So I'm okay. All right. That's why you want to fill it so that actually some of the funnel is filled. Okay, so we have oil, we have water, and we have air. I'm going to put the oil in first. Actually, let me put the water in first. This one, I think this one's going to float the lowest. And I'll hold it up. All right, can you guys see that? It's floating just below the water's surface. Okay, now I'm going to put the oil in. And it's floating just a little higher than the water one. And then finally, let me pull out the water one so we don't have 3 on there. This is the air, which, no surprise, the air is floating on top. Can you see that? Air is on top of the water. The oil is just at the water's surface, and then the water one was floating just a little bit below. Okay, so what that means is water molecules have the same density as water molecules, which is what we expect, and so it would float kind of neutral. The oil is a little bit less dense than water, but because of that, when a shark's fatty liver has lots and lots of fat in it, it also helps the shark remain a little bit buoyant. So if I take some oil and pour it on top of my water, the oil will float at the surface, and you can see that because oil is less dense. It's not packed as tightly as the water molecules are. So when you have less density, then it will float lighter, and so it's more like separate like this versus packed tightly together. There's not as much stuff. There's more stuff packed in this balloon of water molecules than there is stuff packed in this balloon of oil molecules. And there's more stuff in this balloon with oil molecules as compared to the stuff in the gaseous air molecules, right? Air has the molecules that are much further away. We did a little bit about that when we talked about some of the chemistry that we did. I can't remember, was that 2 weeks ago? But we've been doing these every day for a couple of weeks now. This is the end of week 3, and so the days are kind of blurring together for me. But hopefully that gives you an idea of why sharks have to have a fatty liver. They don't have an air bladder like fishes do, like the bony fishes do. And so they have a very fatty, large liver to help them stay up in the water column a little bit longer so that they don't have to expend a lot of energy to do that. So we're going to talk more about sharks when we get together again on Monday. Please join me. We'll be at 3 o'clock again. If you have any questions, feel free to comment and let me know. I will try to respond to those as soon as I can. I've been enjoying this. If you have suggestions or things you want to learn about, things you want to talk about in the ocean, I'm happy to talk about that as well. We could talk for weeks about ocean stuff. I love that stuff. So we just want to have fun. We want to just provide some diversion and give you some opportunities to do some fun activities with your kids, again, using things that you have at home. So thank you for joining me. Have a wonderful, wonderful weekend, and we will catch you again on Monday.